Hey everyone, in this lesson we would like to talk about the mathematical modeling of our system. Now, what are we going to do? We would like to convert any system into a set of equations and then we will see the response of a system. Okay, now if we look at the system, we have a set of equations that describe the system performance. These equations are presented in time domain, right? We usually see all of our equations in our life, we have seen them in the time domain as a function of time. So we have voltage like V equal to V max sine omega t plus a phase shift, right? Okay, now you can see that the voltage is a function of time, right, like this. Okay, function of omega t, function in time. Okay, now you will find that we have in systems, we usually have non-separable differential equations. What does this even mean? It means that in this differential equations, I cannot separate differential equations. I cannot separate the input from the output. An example for this, you have here y dot. Here we have y is our output and x is our input. Okay, now I would like from this equation here, I would like y as a function of x. I would like y in one side equal to x, okay? But you will see that we have here a differentiation of y dot equal to x plus x dot plus 4x double dot. And even we can have more complicated than this. So let's assume that this equation is non-separable. I cannot make y equal to a function of x. So what can we do in this case? That's why in the mathematical modeling in the systems, we use the S domain. The S domain, which will make these equations separable, algebraic equations. Now you will say how. You will see that y dot in the S domain is equal to S multiplied by y. Since it is S representing a derivative, we have x plus x dot, which is S multiplied by x, derivative of x in the S domain, and the double dot is S square of x. So you can see that we can say Sy equal to, take x as a common factor, like this, 1 plus 5 plus 4s square. So we can say y equal to x multiplied by 1 plus s plus 4s square divided by s. So you can see that we now have y as a function of x in another domain, which is the S domain. So by converting a time domain equation into an S domain equation, we can now have or separate y and x. Why is this important? Because in our systems we will have output over input equal to a certain equation, which is 1 plus s plus 4s square over s. This equation here is called the transfer function of the system that relates input with output. So if I would like to say, hey, I would like to find y when x is a step input or when x is the ramp input, you can do this easily in the S domain. Okay, now you will say that this S domain is the one which we'll be using inside our course. Okay, but you all may ask me, what does this even S domain mean? Okay, so I have just shown you that how can I convert an equation like this into S domain. But what does this even S domain mean? That is the real question.